Good morning, everybody. I've made this video in the morning, but I ran out of space. So, let's go ahead and get started. We're going to express these numbers in scientific notation. Actually, we're just writing these out. So, this is going to be, oopsie, let's use purple. It's going to be 123. And then since we're multiplying by 10,000, that's 4 zeros. 1, 2, 3, 4. Just like that. Next one, notice how there's a decimal there, and since there's 3 zeros, we're going to count 3, okay? 1, 2, 3, like that. 1, 2, 3. So it's 3,400. Next one, 0.6 times 100. That's 2 zeros, which means we're going to move it twice to the right, okay? So that's going to be a 60. And last but not least, 7.3. But this time, we're not multiplying it by 10. We're multiplying it by a small number. So notice how we multiply it. We move the decimal over twice. So instead of 7.3, this is going to be 1, 2. So 0.073, okay? And now, the table shows the speed of light or electricity through different materials. Circle the speeds that are written in scientific notation. Write the others using scientific notation. So to give you a heads up, scientific notation looks like this. A number times 10 to the n, where k is between 1 and 10. Okay? And so if you look at these, a couple of these are already written like that. This one is written like that, because 2.25 is between 1 and 10, and this one. But everything else, we're going to have to rewrite them, okay? So, if you remember, this is going to be 3 times 10 to the something. 1, 2, 3, 4, 5, 6, 7, 8. This right here, what I recommend is you put the decimal there, and you go 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 10 to the 8th, and that's a 2.8. Okay? Same thing here. This right here, that's the decimal. 1, 2. So that's going to be 1.24 times 10 squared, right? Because it's 2 times 10 to the 6th. And that's going to be 6 plus 2 is 8. Now this one, it's a little bit tough, but we want the number 0.2 is not between 1 and 10. So instead of the exponent going up, it's actually going to go down. So if we move this 1 to the right, this exponent drops by 1. So that's going to be 2 times 10 to the 8th. Okay? Not bad, not bad. We have to skip this one, because we don't have those cards. And these right here, this one is just 0.9. This one is 0.99. So if you add these, 0.90. So if you add these, you get 0.99. And as a fraction, it would be 9 over 10 plus 9 over 100. And if you do the math, it actually equals 99 over 100. And if you want to know why, you multiply this first fraction by 10 over 10. 9 times 10 is 90 over 100. 90 plus 9 is 99. This one right here, it's going to be 0.9 plus 0.09 plus 0.009 plus 0.0009. By the way, this one should actually be 0.09. Not bad. This adds up to 0.9999. Now, as a fraction, this is just going to be 9 over 10. This is going to be 9 over 100. 9 over 1,000. You get the idea. And if you find a common denominator, it's going to equal 99999 over 10,000. So the answers to the two previous questions have been close to 1. What power 10 would you have to go up to if you wanted your answer to be close to 1 that was only 1 millionth off? You would have to go 10 to the negative 6. And similarly, for the next one, because it's 9 zeros, you would have to go 10 to the negative 9th. Okay? Imagine a number line that goes from your current position, labeled at 0, to the door of the room you are in, labeled 1. So here's 0, here's 1. In order to get to the door, you will have to pass the points 0.9, 0.99, 0.99999, and so on and so on. The Greek philosopher Zeno argued that you will never be able to get through the door because you will first have to pass through an infinite amount of points. So in between, right, this number here and this number, which is just 1, there's infinitely many points. So you're always getting closer and closer and closer. So homie's trying to say that you're never going to get to 1. And just to give you a heads up, scientific notation, this number is not in scientific notation because 32 is not between 1 and 10. 0.9 times 10 to the 12th is not in scientific notation because 0.9 is not between 1 and 10. .14 times 10 squared is in scientific notation because not only is this number here between 1 and 10, but it's also being multiplied by a power of 10, okay? So let's take a look at the homeworks here. Write each number in scientific notation. Once again, oh yeah, I gotta enable the pen. So you start, you start right here and you count 1, 2, 3, 4. Okay? So that's going to be 10 to the 4th, and then you just multiply it by the number in front. 1.47. All right. So if we wanted to write this next one as a power of 10, notice how it's, notice how we have to move that decimal over 1, 2, 3, 4 times. 8.3. But, that's times. But, since we moved it towards the right, that's going to be a negative 4. This next one, here's your decimal. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that's going to be 7.6 times 10 to the 8th. Here's the decimal, 1, 2. And it's negative 1. So it's going to be 3.8 times 10 to the negative 1. How many times did you move it? 0 times, right? 3.8 times 10 to the 0. And, well, okay. You know what? I'm not even going to count. I'm just going to do 3, 6, 9, 12, right? Because it's supposed to be here. So 3.8 times 10 to the 12th. And then this one, okay, we might have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be 9 times 10 to the negative 10. All right, so performing the following calculations. Since they have the same exponent here, we're going to end up just adding these numbers. So that's going to be 8 times 10 to the 5th power. This next one, since it's all multiplication, we can multiply the 2 and the 4.1. That's 8.2 times 10 to the 7th. Multiplication again, so 4.5 times 10 to the 11th. This right here, this is 2 copies, okay? So it's going to be 3 times 10 to the 3rd times 3 times 10 to the 3rd. 3 times 3 is 9. And then 10 to the 3rd times 10 to the 3rd, we're going to add the exponents. So 10 to the 6th. 9 times 3 is 27 times 10 to the 12th. But we're going to write these in scientific notation, right? So 27 is not in scientific notation. We're going to have to move the decimal once to the left, which means this is going to be 2.7 times 10 to the 11th or 13th. If you said 13th, you're right, because we're making this number smaller, which means we have to make this number bigger, okay? I'm going to go ahead and have y'all, actually, no, let's do this. So we have that the Earth and the moon, this distance is 2.389 times 10 to the 5th power. But we also have at the Earth to the sun is 9.296 times 10 to the 7th. And it's asking us how many times bigger is one over the other. And if you want to find that out, you have to divide the two numbers, okay? 9.296 times 10 to the 7th over 2.389 times 10 to the 5th. This is easy. That's just 10 squared. And 9.3 divided by 2.4, that's about 4, okay? You can use a calculator, it might be 3.8 or 3.9. But 10 times 10 is 100, times 4 is 400. So the distance between the sun and Earth is about 400 times bigger, or longer, I should say, than the distance between Earth and moon. It's a lot. And then this one, we have to write the equation, okay? So write a second equation for the system so it has infinitely many solutions. So first, let's find this, okay? Your starting value is -3, and your slope is 3 over 2. So the equation is y equals 3 over 2x minus 3, okay? So if we want to write a second equation so that it has infinitely many solutions, this means it's the same equation, right? Because you want them to cross infinitely many times. Write a second equation whose graph goes through 0, 2 so that the system has no solutions. So using a different colored pen, we want the equation to go through the point 0, 2, but we also want it to have no solutions. Okay, what this means is the two graphs are going to be parallel, so they have the same slope. 3 over 2. So it's going to look something like this. And so the equation would be the same slope, but different y-intercept. Come here, Derpy. Come here. And for this last one, we want a second equation that goes through 2, 2, and it has a solution at 4, 3. Okay? So we want it to go through this point here. Oh, let me use a different color. Let me use red. We want it to go through that point, and we also want it to go through 2, 2. So all I'm doing is just drawing more points, because I already know what the slope is. The slope is up 1, 2 over, so it's 1/2. And it goes through the starting value of +1, and that's your equation. Y equals 1/2 x plus 1. I hope y'all are doing a fantastic time at home. I know times are kind of scary. But yeah, don't forget to submit the homework, okay? Unless you want talking point messages at home. Y'all be safe, alright?